Hello friends, welcome back. In last video we have seen the MO energy level diagram for the HF molecule. Now here in this video we are going to study the MO energy level diagram for the HCl molecule. So let's start with this. So we are having the HCl molecule. So we know that HCl is a heteronuclear diatomic molecules, right? That means it is formed by the two different atoms. So here in this HCl molecule, the two different atoms are the hydrogen and the chlorine. So we are having the first atom. First atom is the hydrogen atom with the atomic number 1. That's why its electronic configuration is 1s1. Whereas the second atom is the chlorine atom. Chlorine atom with the atomic number 17. That's why the electronic configuration is the 1s2, 2s2, 2p6, 3s2 and 3p5. Now out of these two atoms, the hydrogen atom, we can say that this hydrogen atom is the less electronegative atom. Whereas the second atom, that means the chlorine atom is the more electronegative atom. And when the atomic orbitals are formed, the atomic orbitals of the more electronegative atoms, they contribute more to the formation of the bonding molecular orbital and less to the formation of the antibonding molecular orbitals. Whereas the atomic orbitals of the less electronegative atom, that means a hydrogen atom, they contribute more to the formation of the antibonding molecular orbitals and less to the formation of the bonding molecular orbitals. So based upon this, we can say that in case of the HCl molecule, the electrons in the molecular orbitals or the MOs spend more time around one atom than the other. So what happens due to this? This leads to the charge separation. Charge separation, that means it produces a delta plus and the delta minus charge on the atoms. And hence we can say that the HCl molecule produces a dipole. And due to this, it produces a bond, and that bond is a covalent bond which has a partial ionic character. So this is regarding the HCl molecule. So again we can say that in case of the HCl molecule, the less electronegative atom is the hydrogen atom with the atomic number 1. That means the electronic configuration is 1s1. The more electronegative atom, that means the chlorine atom with the atomic number 17. That means the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Now here the 1s2, 2s2, 2p6 and the 3s2. These electrons, they are not used for bonding. Why? Because they are lower in energy, and as they are lower in energy, they are not used for bonding, or we can say that they are non-bonding. Now here the 1s2, we have to use a letter K for the 1s2 atomic orbitals, and we have to use a letter L for the 2s2 2p6. That means for the 1s2 atomic orbitals we have to use a letter K, and for 2s2 2p6 we have to use a letter L. Whereas the 3s2, the two electrons from the 3s, they are neglected. Then we are having a, for the bonding, we are having the single electron from the hydrogen. That means we have to use only a single electron from the chlorine. Single electron from the 3p atomic orbital. Now this 3p atomic orbital again divided into 3, that is 3px, 3py and the 3pz. Now out of the 3p orbitals, only 3px orbital of chlorine will be the most suitable one for the bonding. This is because the 3px orbital matches in symmetry and energy with the 1s orbital of hydrogen. So let's see this diagrammatically. So we are having the 1s orbital of hydrogen. So this is the 1s orbital of hydrogen. It undergo overlapping with the p orbital. This is the p orbital of the chlorine, that is the 3px orbital of the chlorine. So 1s orbital of hydrogen and the 3px orbital of the chlorine, they undergo overlapping, and due to their overlapping we are getting a larger resultant, and that larger resultant is for the plus and the smaller is for the minus. So this is for the HCl molecule, and the molecular orbital form is known as the sigma sp. Whereas the other two 3p orbitals, that is a 3py and a 3pz, they are perpendicular to the bond axis. That means they are not of correct symmetry, and hence they remains as a non-bonding. So let's see this. So we are having the 1s orbital of hydrogen. So this is the 1s orbital of hydrogen, and then we are having the p orbital. So this is the p orbital of chlorine, which may be either 3py or the 3pz. Now from this diagram we can say that they are of not correct symmetry or the matching symmetry, and hence when they undergo overlapping, we get the formation of the orbitals, and these orbitals they are called as the non-bonding molecular orbitals, right? So we can say that only there is a overlapping of 1s orbital of hydrogen and the 3px orbital of chlorine, and they gives rise to the bonding. Bonding means the sigma MO, and anti-bonding means the sigma asterisk MO. So let's see the MO energy level diagram for the HCl molecule. So this is the MO energy level diagram. Again, we know that towards the sides we are having the atomic orbital. So at one side we are having the first atomic orbital. At the second side we are having the second atomic orbital. Whereas at the center we are having the molecular orbital. Again, there are two atomic orbital. They results in the formation of the two molecular orbital according to the LCAO principle. Then again, out of the two molecular orbitals, lower will be bonding, upper will be anti-bonding. Then the first atomic orbital is for the hydrogen atom, and which is named as 1s, whereas the second atomic orbital is for the chlorine atom, and which is named as 3p, and here it is named as the 3px. Then the molecular orbitals, they are for the HCl molecule. The lower bonding is the sigma sp, and the upper, that is the anti-bonding, is the sigma asterisk sp. Now here we can say that the bonding MO means the sigma sp. It is closer to the 3px orbital of the chlorine atom. Okay, that means we can say that it has more character of the 3px orbital, whereas the anti-bonding MO, that means the sigma asterisk sp, is closer to the 1s orbital of hydrogen atom, and hence it has more character of the 1s orbital. So we can say that the 1s orbital of hydrogen and the 3px orbital of the chlorine, they differ in energy. Okay, their positions are different. They differ in energy to some extent. So there is a lack in symmetry in the MO energy level diagram. So as a result, the HCl molecule is a polar molecule, and the HCl bond is a polar covalent bond. Okay, so let's see the filling of electrons. From the hydrogen we are having one electron, and from the chlorine again we are having the one electron. So this is the first electron from the hydrogen and the first electron from the chlorine. Now there are two electrons. Both these two electrons moves to the lower. Lower means the bonding. So this is the first electron from the hydrogen and second electron from the chlorine. So this leads to the formation of the filling of electrons in the bonding, that is the sigma sp. Okay. Then let's see the MO electronic configuration of the HCl molecule. For that, we are having the hydrogen with the atomic number 1. That means the electronic configuration is 1s1. Now, these 1s1 electrons, they are used for the bonding. Hence, we can say that there are no electrons which are present in the K shell from the hydrogen atom. Whereas, for the chlorine atom with the atomic number 17, we are having, this is the electronic configuration. Then, this 1s2 electron, for the 1s2 electrons, in the MO electronic configuration, we have to use a letter K. Why K? Because they are present in the first shell, and that first shell is known as a K shell. Whereas for the 2s2 and the 2p6, we have to use a letter L, because these electrons, they are present in the second shell, that is the L shell. Then for the bonding purpose, we are using only the 3px atomic orbital. 3px atomic orbital overlap with the 1s atomic orbital. Then the remaining means the 3s2, 3py2, 3pz2. All they are neglected. So based upon this, we can say that the MO electron configuration of the HCl molecule is Kl sigma sp2. So this is the MO electron configuration of the HCl molecule. Then bond order, which is equals to 1/2 into number of electrons in BMO minus number of electrons in ABMO, which is equals to 1/2 into 2 minus 0, and which is equals to 1. So the bond order is 1. That means there is a single bond between the hydrogen and the chlorine atom. Then the HCl molecule is diamagnetic. Why diamagnetic? Because the last entering electrons, they are paired. Hence the HCl molecule is diamagnetic. And finally, the bond length in HCl molecule is 1.27 Armstrong unit, and the bond energy is 103 kilojoule per mole. So this is regarding the HCl molecule. In the next video, we are going to study the MO energy level diagram for the NO molecule. Thank you.